In the summer of 1946, in a requisition villa outside Frankfurt, the Americans called Haus Alaska, a 55-year-old German civilian named Wilhelm Fenner sat down to write. He wasn't a soldier. For 23 years he'd run the cipher department of the German High Command, WWII, and now he was the prize catch of an American operation almost nobody has heard of, TICOM, the Target Intelligence Committee, whose job was to track down every surviving German codebreaker and get their knowledge on paper before it walked off into POW camps and civilian life. Fenner was, by American accounts, the best catch they made. He wrote for weeks, over 200 pages in the end, laying out everything his department had broken, how they'd broken it, and, just as tellingly, what they never broke at all. Buried in that second pile, backed up independently by his chief cryptanalyst Erich Huettenhain and by a specialist named Otto Bogisch, who'd spent years personally attacking Allied machine traffic, was one flat fact. No evidence has ever surfaced in the German archive or anywhere else that Germany successfully read operational traffic from America's main Army and Navy cipher machine. Not a captured plaintext, not even a confirmed partial break. 4 years of German listening posts pulling in huge amounts of American radio traffic, and the men whose whole job was cracking codes had nothing to show for it against this one. That shouldn't have been possible. By 1946, everyone already knew the German enigma had been broken, on and off, by British and Polish mathematicians since before the war started. Everyone knew the Americans had broken Japan's top diplomatic cipher, the machine Tokyo called the 97 Shiki Injiki, and Washington called Purple, so completely that American officials sometimes read Japan's cables to its own ambassadors before the ambassadors did. Code-breaking in this war was mostly a story of machines that looked unbreakable and weren't. So what was different about this one machine that nobody on the other side ever found a way into? Not the Germans, who tried hardest. Not the Japanese, who eventually decided it wasn't worth the effort. The answer starts more than a decade before Pearl Harbor, with a man who'd already spent his career breaking the exact kind of machine he was about to make obsolete. His name was William Friedman, and by the early 1930s, he ran the Signal Intelligence Service, the small pre-war office that eventually grew into the NSA. Friedman had built his reputation breaking rotor machines, the family that included Enigma and its cousins. A rotor machine encrypts a letter by running a signal through a stack of wired wheels, each one scrambling it before it hits the next. After every letter, one or more wheels turn, so the same letter typed twice comes out differently each time. Friedman knew exactly where these machines broke, because he'd broken plenty of them. The weak point wasn't really the wiring, it was the stepping. Enigma's wheels turned on a fixed, mechanically simple schedule, not unlike a car odometer, and that regularity gave a cryptanalyst something to grab onto, work out the rhythm, and you had a foothold into the rest of the system. Friedman decided to build something with no foothold. His idea, worked out through the mid-1930s with a young colleague named Frank Rowlett, was to stop stepping the cipher wheels on a fixed schedule and instead use a second bank of wheels to control the first bank's movement. Rowlett's piece of it, around 1934, was realizing a control wheel shouldn't just advance the next wheel by one position on a steady beat. Instead, its output could trigger the movement of one or more cipher wheels in a pattern that was itself scrambled by the control wheel's own wiring. The stepping became encryption driving more encryption. No odometer, no fixed rhythm to find, because the rhythm was being generated by a hidden process inside the machine. On the Navy side, an officer named Lawrence Safford came at the same problem from a different angle and pushed for a version the fleet could actually mass-produce. By 1940, the Army and Navy versions merged into one joint design. The Army called it SIGABA. The Navy called it the ECM. Mark the 2nd around Washington, people just called it the Big Machine. It wasn't much to look at. Where Enigma was compact enough for one field officer to carry and run alone, SIGABA was a heavy box built around 15 rotors in 2 banks, 5 cipher rotors, 5 control rotors, and 5 more index rotors governed by the control bank, all wired together specifically to keep a skilled cryptanalyst from ever finding a repeating pattern. One trained operator could run it, though Army and Navy practice usually put a second person on hand to help with traffic, and for anything high priority, procedure called for check deciphering the message on a separate machine with a different set of wheels before it went out, just to catch operator error. It was too big and too fussy to hand to a rifle platoon, so it never became the everyday workhorse the way lighter systems did. But, for the traffic that mattered most, headquarters to headquarters, fleet to fleet, Washington to its field commanders across 2 oceans, SIGABA and its Navy twin carried a large share of America's most sensitive wartime communication. Under 10,000 were ever built, most assembled under heavy security by the Teletype Corporation in Chicago, and plenty of field units carried thermite kits, so a machine at risk of capture could be destroyed on the spot. None of that caution was paranoia. The American cryptologic establishment knew exactly how a machine cipher falls, because they'd just finished breaking Purple and its relatives. It falls to patient traffic analysis, to captured hardware, to operators who get sloppy and reuse keys, to mathematical structure that lets an analyst work backward from ciphertext to wiring. SIGABA's designers spent years trying to shut every one of those doors before the war even started, because they'd personally kicked those same doors open on somebody else's machine. Then the war put the theory to the test on 2 fronts at once. On the German side, the outfit chasing Allied cipher traffic was Fenner's WWII, working alongside a separate army group, and Fenner's top mathematician, Erich Huettenhain. German signals intelligence had real successes in this period. They read French diplomatic traffic. They cracked a range of lower-grade Allied Army and Air Force codes. Against tougher targets, they made partial headway too, picking apart pieces of British hand ciphers and getting deep enough into the American State Department's diplomatic strip cipher to understand a lot about it. What they never managed, according to Fenner's own account, Huettenhain's separate interrogation, and a detailed TICOM report on German attacks against British, American, Swedish, and French machine ciphers, written by a cryptanalyst named Fritz Barthel, was any sustained break into America's primary Army and Navy machine traffic. The post-war American review of the captured German material puts it plainly. Nothing in the TICOM record suggests Germany, Japan, or anyone else ever solved this machine's output. It wasn't for lack of trying, and it wasn't for lack of raw material either. German stations along the Atlantic coast and across occupied Europe pulled in enormous quantities of American military radio traffic. Some of it sat in weaker codes German analysts genuinely could read, which gave WWII a real, partial window into American logistics and troop movements at the tactical level. But the high command traffic, the stuff that actually decided the big strategic questions, kept landing on German desks as columns of letters with nothing to grab. Breaking a rotor machine means finding its fingerprint, some statistical tick, some repeating cycle that gives away how the wheels move. Against Enigma, Bletchley Park found exactly that, helped along by sloppy German habits, captured machines and code books, and a real design flaw, since Enigma's reflector guaranteed a letter could never encrypt to itself, which cut the search space down dramatically. SIGABA had no reflector and no fixed stepping period to lock onto, because a second layer of wheels was scrambling the stepping itself. Modern studies done after the machine was declassified in the mid-1990s generally back up the idea that even with full knowledge of its internal design, its key space gave it a real margin against anything 1940s technology could throw at it, though exact figures shift depending on which configuration a study assumes. The Japanese ran into the same wall from a different angle, stretched thin and already busy patching their own compromised systems. Their cryptanalysts looked at intercepted American traffic and, by the post-war record, made little visible progress before deciding their limited resources were better spent elsewhere. This is the part of the story that's easy to undersell, because nothing dramatic happened. No captured machine, no daring raid, no code clerk who got careless. The whole arc of SIGABA's war is an absence, and absences don't make for good drama. But set it against the other two legs of the same triangle. Enigma, which the German High Command trusted with its most sensitive traffic, was broken by the British and Polish for most of the war. And that broken traffic, Ultra, shaped campaigns from the Atlantic to Normandy. Purple, which Tokyo trusted with its most sensitive diplomatic cables, was broken by Friedman's own service before Pearl Harbor. And that traffic, magic, gave Washington a window into Japanese intentions for years. Two of the three major cipher systems of the war fell. The third, as far as the surviving record shows, didn't. And it belonged to the same country, built out of the same small pre-war office, designed in large part by the same man who'd helped break the other two. Worth saying clearly, America wasn't the only Allied power whose communications held up well. British systems also gave Germany plenty of trouble. But among the big players, this looks like the one case where the main machine cipher was never, by any evidence anyone's found, cracked at all. That mattered in practical terms. A big share of the traffic deciding the largest strategic questions, fleet movements, the pacing of the Pacific War, much of the planning behind Overlord, could travel by radio in a form the enemy could listen to all day and get nothing from. Not everything moved that way. Plenty of sensitive planning still went by courier or secure landline, and SIGABA was one piece of a much bigger security system, not the whole of it. But for the radio traffic it did carry, the confidence behind it held up. Every other major power in the war found out, at some point, that its own supposedly secure command traffic had been read by somebody. Germany never learned exactly how much of its Enigma traffic had gone. Japan never learned exactly how much of its purple traffic had gone. On this one front, the United States sent its most important orders across an ocean, and nothing in the record since has ever shown that trust was misplaced. Fenner spent more than 20 years running an agency, built to listen in on the enemy's secrets, and the war ended with him writing, in his own hand, that against the one system that would have told him the most, he'd found nothing. He wasn't tried for war crimes, wasn't especially villainized by the men interrogating him. He cooperated, was eventually released, and died quietly in Germany in 1961. Bugish wrote his own detailed account of exactly how those attacks failed, and historians still read it today because it's one of the clearest first-hand descriptions anyone's written of what it feels like, from the losing end, to run out of footholds against a machine built by someone who already knew every foothold you'd try. Friedman never got his own dramatic wartime moment out of SIGABA, not the way Bletchley did with Enigma, or his own team did with Purple. No triumphant decrypt, no message that turned a battle, because the entire point of the machine was that nothing ever came out the other side. He spent the rest of his career mostly out of public view, and SIGABA's real story stayed classified until 1996, decades after the machines themselves had been pulled from service and mostly destroyed. For 50 years, the story people knew was Purple, the code America broke. The one nobody could prove anyone else ever broke just sat in a vault, unremarkable by definition, because a system that works perfectly doesn't leave much of an archive behind. Everyone remembers the codes that fell. Almost nobody remembers the one that didn't. What's left of it is a German cryptanalyst in an interrogation villa in 1946, writing down exactly what his department never managed, and 15 rotors under glass in a museum case, having spent 4 years of the deadliest war in history telling nobody who wasn't supposed to be listening anything at all. If you want the next one when it's ready, subscribing gets it to you. And if this was worth a few minutes, a like helps more people find the parts of the war that almost slipped past everyone.